This is section 4.1. We're going to talk about functions of several variables, domains, level curves, and level surfaces. Let's just start out with functions of two variables rather than several. We can picture a function of one variable, y equals f of x. We can visualize that as a curve. We can plot the x, y points on that curve. Any point x and y that satisfy that equation will be on this curve, and our domain lives down here, and our range is the set of y values that the function takes on. A function of two variables can be visualized as a surface. So z equals f of x comma y. The x, y's are down here. This is the domain. So now the domain's going to live in two variables. And the range will be the set of z values that the function takes on, so they will lie on this axis. And you can see we've got a surface there. And so let's practice finding some domains. The rules for domains that we learned for functions of a single variable still hold. You can't divide by 0, you can't take the square root of a negative number, and you can't take log of a negative number. So let's look at some problems. H of xy equals 1 plus 4x squared plus y squared. So the domain is all xy because there are no fractions, so we can't run into trouble there. There's no square roots, there's no logarithms. Nothing could go wrong. We can put any x in, any y in, and our function will be fine. So not much of a graph, you just sketch in the whole xy plane. But for this one, we want to graph the actual surface, which we can do, because this happens to be one of the quadratic surfaces that we learned about in I think it was section 2.6 or something. I can't remember the number. But if I write this as z equal 1 plus 4x squared plus y squared, I see this is an elliptical paraboloid. And you might not recognize it as such because when we talked about elliptical paraboloids, they looked like z equals ax squared plus by squared. There's an extra 1 here, but the only thing that does to the graph is it lifts it up 1 unit. So instead of looking like a bowl that is centered at the origin, this is going to look like a bowl that goes through 1 on the z-axis. And so you can get the range by just looking at that. The range is going to be z greater than or equal to 1. Or in interval notation, that would be 1 to infinity. Okay, let's look at one where there are some issues. The domain's a little bit more interesting. This first one's a fraction. Don't worry, I wouldn't expect you to be able to graph that. If you had to graph that, you would want to go to 3D Calc and do it with technology. But we can graph the domain. What we need is that the denominator should not be 0. So x squared plus y squared minus 25 can't be 0. So the domain is going to be all xy except x squared plus y squared equals 25. So the way to say that is you could write all xy except x squared plus y squared equals 25, or you could just say the domain is all xy with x squared plus y squared not equal to 25. So we can actually take a look at what the boundary of the domain is going to be the circle x squared plus y squared equals 25. And so that's a circle of radius 5. That's the boundary of the domain. And we want all xy except for the points on that dotted line. So anything inside the circle is fine. That would be in the domain. And anything outside the circle is fine. That would be in the domain. And the reason why I used a dotted line for the that boundary curve, x squared plus y squared equals 25, is because those are the points that are not in the domain. And so up in red here, I said, use a solid line if it's part of the domain and a dotted line if it's not. Somehow I switched pens. Okay, let's look at another one. Logarithms. Remember the rule for finding the domain of a log. You take the argument and you set it strictly greater than 0. So we need x squared minus y to be strictly greater than 0, because you can't take log of a negative number. You also can't take log of 0. So that means y should be less than x squared. So the boundary curve for the domain is going to be, the boundary is the dividing line. The dividing line will be the parabola y equals x squared. Let me draw that. And since those points are not in the domain, I'm going to dot it in. This is y equals x squared. And I want all xy with y less than x squared. So that's going to be all the points below that parabola. And that's what your domain looks like. All right. Next one. Note on homework, you will sketch the boundary with a solid line and then answer the questions about what points are in the domain. So they had to come up with some creative ways for you to be able to sketch domains. So it's slightly different than I'm doing it here. But for this problem, again, we can't divide by 0, so we need x plus 6 not to be 0. So x should not be negative 6. So the boundary of the domain is going to be x equal negative 6. I'm going to dot that in. This is the line x equal negative 6. And I'm using a dotted line because those points are not in the domain. Any other coordinate pair xy is in the domain. So I'm going to shade in this side of that dotted line and this side. All those points that I've shaded are in the domain. So on your homework, that I remember now, they're going to have you use a solid line to graph that x equal negative 6, and then they're going to say, okay, which points are in the domain? And they're going to say, are points over here in the domain? Are points over here in the domain? So on and so forth. Okay, last one. We've got a square root. Rule for square roots is you take the argument and you set it greater than or equal to 0. 4 minus x squared minus y squared greater than or equal to 0. So it's like logarithms, except you include 0 because it's okay to take the square root of 0. So that's x squared plus y squared less than or equal to 4. So the boundary will be x squared plus y squared equals 4. That's a circle of radius 2. And I'm going to use a solid line for once because those points are actually in the domain. The points on that circle aren't excluded. They're in the domain, and so are all the xy inside of the circle, because those are the points where x squared plus y squared is less than 4. So we want the boundary, which is equal to 4, and then all the points inside, which would be less than 4. And what is that surface? If you write it as z equals the square root of 4 minus x squared minus y squared, and then square both sides, z squared equals 4 minus x squared minus y squared, and then move the x squared and the y squared over, you see that it's a surface, sphere of radius 2. So the whole thing is a sphere of radius 2, but since we're taking the positive square root, we're only getting the top of the sphere, like that. That's not my best drawing, is it? Okay, level curves and contour curves. A level curve is the set of all xy where the height of the function is constant. So f of xy is a constant. That's equal to c. If you've ever read a topo map, if you've gone hiking, that's a representation, a 2D representation of level curves. So you might see, if you look at a topo map, you might see a bunch of lines like this. These lines indicate curves in 3 space where the height, the elevation, is constant. Okay, the difference between a level curve and a contour curve is that contour curves live on the surface, level curves live below the surface. Okay, so here's a picture of that. Suppose this is my surface. The level curves are going to lie in the plane. Those are curves on which the surface height is constant. If you want to picture those curves on the surface, you just call them contour curves. So contour curves live on the surface, whereas level curves lie in the plane. Let me show you a neat way to see these with Calc 3D. Here I've got a surface. You can see it lies above the XY plane at times and below the XY plane. If you click on this icon here, it'll give you some options. I'm just going to click on Create Plot and use the default. It gives me the curves. These are level curves. These are curves in the XY plane over which the height of the surface is constant. And you can see over here, I've got positive heights. That means Z is positive. And over here, I have negative heights. Well, down here, I have negative heights. It doesn't make sense to make a negative height, but yeah, it does actually. Z is less than 0. If you want to see these actually on the surface, what you do is just click once anywhere where the surface was before, and the computer program will put those curves back onto the surface. And so you can see over here, we've got positive heights, Z is positive, and down here we have Z is negative. So it's pretty neat. Okay, so how do you find these analytically without looking on Calc 3D? Well, first let's look on Calc 3D for this one. This is the top of a cone, square root of x squared plus y squared. So let me clear that out. And then Z is, I think square root is just going to be SQRT. And then it was x squared plus y squared. Okay, enter. All right, there's our cone. Let me get rid of the box and get rid of the stupid edges. All the heights are positive, and you can almost visualize the level curves are going to be circles, right? Let me show you that. Bunch of circles. Well, if I put them back on the surface, you'll see, oh yeah, the places where Z is a constant height, those are circles. All right, so let's go back and do that analytically. Identify the surface and sketch it. Okay, so this is the top of a cone. So we did that part. That's part A. Part B, find an equation of the level curve corresponding to C equal 2 and sketch it. So what we want to do there is set f of x, y equal to 2. All right. So f of xy is the square root of x squared plus y squared, and I'm setting that equal to 2. All right, if I want to recognize that as something I know, square both sides. X squared plus y squared is 4. That's a circle of radius 2 in the xy plane. Okay, and there's my level curve. All right. That's B. For C, we're going to find a level curve, but the information is given to us a little bit differently. Find an equation of the level curve that passes through 0, 1 in the xy plane. So this is a two-part process. First, we need to find C. Find C. And the way we'll do that is C is going to be equal to f of the point given to us, 0, 1. Okay, so that's square root of 0 squared plus 1 squared. Square root of 1 is 1. So C is 1. And so we want to find all the points x, y where the surface has height 1. And so it's part 2. So now set. Now we're back to part B. We take f of x, y, and we set it equal to c, but c is 1. So that's square root of x squared plus y squared equals 1, or x squared plus y squared equals 1. Circle of radius 1. Okay, next one. F of xy is 4 minus y squared. Okay, you may or may not remember from our lecture on quadratic surfaces, if there's a variable missing, you've got a cylinder, okay? And so here I see that x is missing, so this is going to be a cylinder, and in order to graph this cylinder, I would look in the YZ plane, I would graph that curve. Here's Y, here's Z. That's a parabola, and it opens down, right? And then I would extend along the missing variables. So the missing variable's x, and so I'm going to get something that looks like an airplane hangar. Shout out to Summer, who's in the Navy. So let me do this on Calc 3D. Z equals, let me just go back to the default, 4 minus y squared. Okay, zoom out, get rid of those edges, get rid of the box. There we go. You can see that the level curves, if you imagine slicing this surface with a horizontal plane and projecting downward. If I slice with a horizontal plane, like z equals 1, I'm going to get 2 lines. Enter. Well, it's not going to let me. Okay, add another function. Z equal 1. Come on. There you go. Okay, there you go. 2 lines. So in general, no matter what height I pick, I'm going to get 2 lines as you move this plane up and down, except there's one value of z up here where I'm only going to get a single line, and that's like the ridge of the airplane hangar. All right, so back to our thing here. So part B, what's part B? Find an equation for the level curve corresponding to c equals 2. So we want to set f of xy equal to 2. So 4 minus y squared equals 2. So y squared is, move the y squared over, so y squared is 2. So I get 2 lines. Y is plus or minus the square root of 2. So I'm getting 2 equations, not 1. So this is 2 lines. Here's the xy plane. I'm going to graph my level curves. This is x, this is y. Those are horizontal lines. One up here at root 2 and one down here at negative root 2. Okay, and let's find another level curve. Find the equation of the level curve that passes through 0, 1. So for C, first we need to find C. Find C. And the way you do that is C is going to be f of 0, 1, which in this case is 4 minus 1, which is 3. So now set f of xy equal to 3. Okay, so we set 4 minus y squared equal to 3. And that gives me y squared is 1. So y is plus or minus 1. So that's 2 parallel lines. Here's 1. Here's negative 1. Looks a lot like the one above. All right. So that takes care of the difference between level curves and contour curves. I'll never ask you to graph contour curves because that's going to force you to actually draw the surface and then put the curves onto the surface, and that's kind of tricky to do in 2D. I'll ask you to draw level curves though all the time, And I'll ask you in two different ways. I'll either give you C directly, okay, in which case you're going to just, you're going to graph the curve f of x comma y equals C. Or I'll give you a point and I'll say, graph the, find the equation of the level curve that passes through that point. That's a two-part thing. The first thing you'll have to do is find C, and C will be f of, well, whatever point I give you. If I give you AB, C will be f of AB. That'll be step one, and then you'll look at the curve f of xy equals C, like you did in the first case. All right, and that is it for this section. Got some practice problems here. Find the domain and sketch it. Use dotted lines or solid lines where appropriate. Got a nice inverse function there for you. And then here I ask you to find a level curve corresponding to a C. And then this last one, I ask you to find another level curve, but this time I give you the point, so you have to first find C, then find the level curve. And I've got the answers. Don't look. Got the answers there. So go through and do these and make sure when you upload your lecture notes that you've done these practice problems. I don't care if you have to look at the answers. That's fine. You're learning. And that is that section. All right. Bye.